Hello everyone and welcome back to another video. Today we're going to be trying a problem from the 2024 Yale M-Maths competition on the team round. I actually wrote this problem for the competition and it ended up being one of the hardest on the team round, problem 11 out of 12. But I want to talk about this problem because I think it's actually very manageable if you come up with the right ideas. So let's just go into what the problem is saying. It looks very daunting at first, so let's try to break it down. The problem defines a sequence am, n and defines it as such. So just first to understand what's going on here, when you write am, n, that means you're defining a sequence that's basically on two variables, m and n. And depending on what m and n are, you're going to get different values. And so usually when you think of a sequence, you think of one variable, and we're going to get to that eventually. But this one's defined on two variables. So it starts with saying the sequence is 0 when n is less than 0. It's 1 when n divides m, basically. So n is equivalent to 0 mod m. So this might be n is m, 2m, 3m. And then otherwise, you get this very weird expression where it's like am, n minus 1 plus am, n minus m. So the first thing you should notice in this problem is that if m is constant, this defines a completely new sequence. So let's say if you took, for example, m equals 3, you get a whole sequence, a3, n, which is defined like this. 0 if n is less than 0. 1 if n is equivalent to 0 mod 3, and then a3 n minus 1 plus a3 n minus 3 elsewise. And since the sequence here never moves away from m equals 3, you can basically just kind of drop the 3. Just kind of ignore it and think of this as sequence in terms of n. Because everything else just depends on n here. So for like an easier example, let's try m equals 3 here. And let's just go from n equals 1, 2, 3, 4, 5, 6, 7, 8. Okay. And of course, I should say n equals 0. Okay. So starting with n equals 0, 0 is 0 mod 3, so we get a 1. N equals 1 is not 0 mod 3, so instead we get a 0, because it's a n minus 1, plus a negative 2, which is 1 minus 3. But for n equals negative 2, that's less than 0, so we just get 0. So that term cancels out. We just get a 0, which is just 1. Same thing happens for n equals 2. You get it's equal to a2 here, or sorry, a1, because 2 minus 1 is 1, and then plus a negative 1, which is 0, so you just get 1 again. Okay. Now back to n equals 3. 3 in this case is 0 mod 3, so that's easy, 1. Now this is where it gets interesting. If you choose n equals 4, that means you get a3, 3 plus a3, 1, because 4 minus 3 is 1. And a3, 1 is 1, and a3, 3 is 1, so their sum is 2. Okay, let's try n equals 5. This is a3, 4 plus a3, 2. Now a3, 4 is 2, and a3, 2 is 1, so their sum is 3. Okay, n equals 6. Once again, easy. It's 0 mod 3. It's divisible. 3 divides 6. So we get a 1 there. Now, n equals 7. That's going to be a3, 6 plus a3, 4. a3, 6 is 1. a3, 4 is 2. So our sum is 3. Finally, n equals 8. is A37 plus A35. A37 is 3, and A35 is also 3, so we get 6. Okay. This seems kind of weird. I don't know. When I look at this, I don't see anything jumping out to me, except for maybe there's a lot of ones here, and then it starts getting larger. But one thing you might realize, and this ties into the fact, well, we'll get to that. One thing you might realize is that the sequence kind of restarts every time you get to something that's 0 mod 3. So it starts at 1 here, it restarts here, and it kind of restarts here again. So it kind of gets reset back to 1. So a helpful idea is maybe we should think of these in groups of 3. Okay, let's try to draw that out and see what happens. So keep in mind, this is still m equals 3. We'll have one row that's n equals 0, 1, and 2. Then n equals 3, 4, and 5. And then n equals 6, 7, and 8. So he said 0, 1, and 2 are all 1. 3 goes back to 1. 4 goes to 2. And then 5 goes to 3. 6 goes back to 1. 7 goes to 3. And 8 goes to 6. Okay, so this is what we got. The first thing you should realize is the number right here is related to the answer we wanted from the beginning. So if you look at the question, it asks for this like a of 2025 comma 2025 squared minus 1 over a of 2024 comma 2024 squared minus 1. And that squared might make you think of something like a square here. In fact, this 6 is a3 comma 8, which when m equals 3 is am comma m squared minus 1, which is of the form that we want. So this should give you a hint that we're on the right track. Now the question is, what is this number? Now many of you might already see a pattern here, but let me try to hint at it. So there's a reason why it's helpful to think in groups of 3 here. And the reason why is that in the definition, we get that an comma m is it's am comma n is am comma n minus 1 plus am comma n minus m. So for m equals 3, look what happens. Let's say we're trying to find what this value is. Well, am comma n minus 1 is actually the term right before it, and am comma n minus m is the term right above it. So once again, this is a3 comma 6, and we want that to be a3 comma 5 plus a3 comma 3. Yes. Oh, sorry, this is n equals 7. So that should be a 7, that should be a 6, and that should be a 4. So a3 comma 6 is right there, and a3 comma 4, well, you just have to subtract 3, which is equivalent as going up a row, is right there. So every single number in the sequence is just the sum of the number behind it plus the number above it. So this is a really helpful way of thinking about the problem. Now I think we can try a larger example. Let's try m equals 4. So once again, we're going to try to group into groups of 4 this time. 0, 1, 2, 3. N equals 4, 5, 6, and 7. N equals 8, 9, 10, 11. And then finally, n equals 12, 13, 14, and 15. Okay. So all of these are going to start at 1 up here. And the reason why is if you subtract 4 from any of these, you're going to get a negative number. So it's the same as the one before it. You can think of that as all the numbers up here as being 0. And so if you're summing the number before it plus the number above it, you get just the number before it. Okay. Now, going back to n equals 4, that 4 is 0 mod 4, so you get a 1. Now this one, you sum the one before and the one above it, that's 2. 3, 4, go back to 1. Now I get 3, 6, 10, go back to 1. Now I get 4, 10, 20. Okay. So hopefully a pattern should be revealing to you right now. And the reason why is it's connected to this idea of summing the one before it and the one above it. And it should be related to something called Pascal's triangle, which hopefully you've seen before. And I'll draw out a couple rows of it to see if you recognize the pattern. And 1, 5, 10, 10, 5, 1. Okay. So you'll actually notice that the diagonals of this square are Pascal's triangle. 1, 3, 3, 1. There's an imaginary 1 here, 1, 4, 6, 4, 1, and so on and so forth. So this square actually generates Pascal's triangle in a kind of weird way. Okay, this is a great realization, and it's going to help us solve the problem. So we need to relate what part of Pascal's triangle this number is. So the first thing you should try to figure out is what row of Pascal's triangle is this related to. So this number, this diagonal is row 0. This diagonal is row 1, 2, 3, 4. Okay, that means this diagonal is row 5, and then this diagonal is row 6. Okay. And another way we can get to this 6 number here is you go to the third row, which is in this case m minus 1, and then you add on 3 extras. So boom, boom, boom. So basically, if we had to come up with a formula for it, it would be m minus 1, which is 3, plus m minus 1, or 2m minus 2. Okay. Now we need to find in what place in the row is this number. So you might realize that this is dead center in the row. There's the exact same numbers before it as there are numbers after it, which means it has to be in the center. So in fact, if the row number is 2m minus 2, the center is that divided by 2, or it's the m minus 1th number, where 0, you start at 0. So we're trying to argue that 20 is 2m minus 2, choose m minus 1, where m equals 4 in this case. Let's see if that's true. So if I plug in m equals 4, that would give me 6 over 3, which equals 4 times 5 times 6 over 3, which, 3 factorial. 3 factorial is 6, so these cancel, and you just get 20. So yeah, this works. If you would like to, I recommend trying m equals 5 on your own. You'll get that the corner should be 70, this being a5 comma a5 squared minus 1. And 70 is indeed equal to 8 choose, sorry, there shouldn't be a 4 there. Or there shouldn't be a bar. 8 choose 4. Okay. So now that we have an agreement of what the correct term is, let's try to actually solve the problem. So we're trying to figure out what a 2025 comma 2025 squared minus 1 over a 2024 comma 2024 squared minus 1 is. Okay. So this is m equals 2025, and this is m equals 2024. Plugging that into our equation, we get that this should be 4048 over 2024. And this one should be 4046 over 2023. Okay. Simplifying that a little bit, this should be equal to 4048 factorial over 4046 factorial times, and then you get a 2023 factorial squared over 2024 factorial squared. And this is because 4046 over 2023 is just 4046 factorial over 2023 factorial times 2023 factorial, mainly because it's the exact number divided by 2, so you get it twice. Now this cancels out nicely. It goes to 4047 times 4048. And the other term cancels out nicely because 2024 factorial is just 2024 times 2023 factorial. So we just get two terms of 2024 in the denominator here. This has an extra term of 2, which cancels out with this to get 1012. So you get 4047 over 1012. And this is finally in a reduced form. And the question asks for this being a over b, and it asks what a plus b is. In this case, that is 5059. And that is the correct answer. So the main realization for this problem was realizing that we can write our sequence in terms of a square. And once we do that, it becomes pretty obvious that we're actually just generating Pascal's triangle. And there were a couple of ways to come to that realization. The first one was literally how the sequence is described. That's n minus 1 plus am comma n minus m. Is this way inherently in the description where you're going one back and you're going back a row. And that's the exact same way you can think about Pascal's triangle, is you're adding two numbers together, except it's kind of rotated in a weird way to make this work. And the final realization that took that was realizing that you're doing this kind of resetting every m terms. M equals 4 here, so you could think of that as grouping into 4s, write that as a square, and you get the correct answer. So really interesting problem. It seems daunting at first, but if you come up with the correct realizations, you can get it pretty quickly. It has a very simple result, simple expression, and simple answer. Okay, thank you guys.